shortcut is the number of zeros is 1 less than this. Or you can just do it mechanically the way I just did. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 3, 2, 7, 5. Super tiny number. Okay? The next one. How many jumps? To the big side or the small side? This one has lots of jumps. Now, I'm going to have to make a few jumps to get past all these decimal digits. 1, 2, 3, 4. How many zeros does that leave? Leaves 11 zeros. Because I used up 1, 2, 3, 4 jumps. I got 11 more because I had to make 15 total jumps. Whatever, let's just do it the mechanical way for now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Fill it in with zeros. And typically you want to copy it over because it's kind of gross to look at. So, comma here, comma here, comma here, comma here, and here. So I have, this is the number of grains of sand at Jones Beach. No, I don't know what this is. Probably a bigger number than 10. 100,000, million, billion, trillion, 5.4 quadrillion. Questions there? What I was saying about the number of zeros is, if you count up the jumps, again, the shortcut, it's not necessary to know this, you can ignore me if you don't follow this. I have a total of 15 jumps that I get to use. It takes me 1, 2, 3, 4 jumps to get here. That means I've used 4 out of 15 jumps just to get to where I'm past the last digit. Then I got 11 more to use up the full 15, so there should be 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see what I'm saying? It's a shortcut or a way to check your work. Or you can just, like I said, just do it mechanically. So, big number or small number?
Small.
So 0.000211, right? And then this, I recommend that you, in fact, whenever it's addition or subtraction, you want to do that in standard notation. You don't want to try to add these together. That's massively confusing. So this is what, 2450 plus 52250, is that right? 1, 2, 3, 4, yeah, we get 1 0 on this guy. So we have a total of 54,700. Okay, so again, addition, subtraction, you want to go ahead and do in standard notation. That's why I threw in those last examples on each of those. It's entirely too confusing to do them in scientific. Okay, that leaves us with 2 topics. How do I divide? How do I multiply and how do I divide scientific notation numbers? And I'm going to show you how to do it on the board. And then we're going to see what kind of calculators you guys have. Because you might be able to do it on your calculator. It depends on what calculator you have. So, if I have 3.547 times 10 to the 8th, and someone says, go ahead and multiply that times, I don't know, let's do 2.24 times 10 to the 10. Now, this is interesting. That one homework problem where everything was multiplication, I said you could use commutative property to move stuff around. Do you see any addition or subtraction up here? No. So, beautiful thing is, I can move the 2 decimal portions together. So these get multiplied. And I can move the 2 tens portions together. Just write it this way so it looks consistent up here. And this is cool. We know what to do with these exponents, right? What do you do with these exponents? Yeah. So we have 10 to the 18th. That's all taken care of. put this in your calculator and you get something around 7.94528, and you're done. How easy is that? Questions on that? There's one little curveball that I need to throw at you for this multiplication business, and then you're out of the woods on this. When you multiply these, did you still get a single digit with decimals? Yes. I intentionally picked these to be easier type. Watch what happens if we have 5.78 times 10 to the fifth multiplied times 8.24 times 10 to the 8th. Well, start off the same way. I'm going to put my decimal portions together. We'll multiply those in a second. And then I could probably just skip a step and just write 10 to the 13th, right? That's always going to be the same thing. Just add the exponents, as long as it's multiplication. What do you get when you multiply these? Okay, 47.6272. Is this okay, or is this breaking our rules of scientific notation just a little bit? Yeah, what's wrong with this?
Should be to the 10.
Has to be a single digit to the left of the decimal. So I really need to write this as 4.76272, right?
Right. From 10 to the 14th.
Yes. Here's the confusing part. The way to think about this is, you're correct, Anthony. The way to think about this is as follows. These numbers need to equal each other. I'm not, in fact, I want you to know something. I guess I forgot to say this. Maybe it's obvious. This and this are equal. This is just two different ways of writing the same number, right? If you put this in your calculator, that's why we did that calculator thing. If you put this into your calculator, it's going to tell you that's 917. If you make a big enough number, it's going to actually go to scientific notation because it's going to run out of digits. The reason I'm mentioning that is that this and this need to be exactly the same number. They need to be equal. And here's the thing. It's kind of like balancing this out. When I went from 47.6 to 4.76, did I make this decimal portion bigger or smaller? No. From here, let's make the 0 look like that. When I went from here to here, is 47 becoming smaller? It is. To balance that out, I need to make this portion bigger. That's the only way I can come up with after years of teaching this that people seem to latch on to. You're not allowed to use two digits over here. You need to fix that, so you have to do this part. Well, you shrank 47 down to 4.7. That's a shrinkage by a power of 10. So to balance that out, you've got to boost your power of 10 over here so that you still have the same number. Does that make sense to you guys? Usually people feel pretty decent about that. You can't just memorize. If it's multiply, I'm always going to be making the exponent larger if I have to do this. Notice, you don't always have to do this. If when you multiply these, you're still within the guidelines for scientific notation, then you just use 10 to the 18th. It's when you multiply these and you blow past 9.9999 because of the size of these two numbers that you're going to have to make this adjustment and pick this up a notch to offset the fact that you had to shrink your 47 down by 1. Okay? All right. Let's look at dividing. I'm going to do the straightforward one where no adjustment is required for dividing, and then a similar thing will happen over there where sometimes you divide and something happens that you need to adjust.